Okay, so here's a perfect example of an ideal gas law. What is the pressure in atmospheres of 0.0034 moles of argon gas in a 75 milliliter incandescent light bulb at 20 degrees Celsius? So what I notice first is there's no change, right? There's no change in anything. There's no change in temperature or pressure. So I'm probably using PV equals nRT. So if I'm using PV equals nRT, I'm going to try and find all the variables I want. So what are the moles? How many moles do we have? So from the problem, moles is 0.0034. The volume is 75 milliliters. Let's put this as moles. Temperature is 20 degrees Celsius. And what's pressure? Oh, they said, what is the pressure? That's my unknown. And then R is something you'd be given on the test. So let's go back up here. 0.0820, is that 58? Liters times atmospheres over moles times Kelvin. So I'm going to want to find pressure. So I'm going to rearrange the ideal gas law. Pressure is equal to nRT over V. Now, I can't just plug these in. What units do I need? Okay, what about volume? What should I do to the volume? Anybody? Can I fix that?
Convert it to liters?
Yes. So 1,000 milliliters over 1 liter, and I get 0.075 liters. And the temperature, most certainly, all the gas laws have to change the temperature, 273.15. So that'll be 293.15 Kelvin, accurate to the ones place. I'm going to plug in everything. 0.0034 moles of gas. It doesn't really matter what the gas is as long as I know the number of particles, times the gas constant, 0.082058 liters times atmospheres over moles times Kelvin, times the temperature, 293.15 Kelvin, over the volume, which is 0.075 liters. What happens to the units? Let's check this out. I have Kelvin here, cancels with Kelvin in the denominator of the gas constant unit, and liters in the numerator cancel with liters in the denominator, and moles in the numerator cancel with the moles in the denominator of the gas constant. I'm left with atmospheres. That's good. That's what I want. So then my answer will be in atmospheres, and I just need a calculator. How many sig figs will I have? So the leading zeros don't count on the volume or the moles. So both of those are 2 sig figs. It was 1.0905. So what would that be to 2 sig figs?
1.1?
1.1 atmospheres. Good. So that's my answer to that one. So what did I found the pressure. So given NTV, I found P. That was the idea, right? Okay, so we continue. Okay, so I'm going to do some more practice ones with this, but basically the idea, we're not going to do all the cases, but, you know, read your problem, right? Read your problem. Look for your variables. What are your variables? Rearrange it to solve for the unknown, right? Plug it in, sig figs, done, basically. Okay, I know I make it sound easy, but you guys will get it with practice and stuff, I'm sure. Okay, so this one says at what temperature will 0.0421 grams of argon in a 23 milliliter incandescent light bulb have at a pressure of 752 millimeters of mercury? So I guess what you can see is this can be kind of tedious just with unit conversion sometimes. So let's see, my pressure is 952 millimeters of mercury. My volume is 23 milliliters. I don't have moles, but I have 0.0421 grams of argon. Can I find the moles? And so obviously I'm trying to find the temperature, right? Remember, R is still 0.082058 liters atmospheres over moles Kelvin. So I need to find I need to change all these units. So if you remember from before, I'm going to just give you the relationship between millimeters. There's 760 millimeters in 1 ATM, 1.2526, 3 sig figs, and that's atmospheres. Just divide by 1,000 milliliters and I get 0.023 liters. And then let's convert the grams of argon to moles. I need the molar mass. I'm going to look up on the periodic table. And argon is 39.95 grams to 1 mole. So this is going to be a really small value then. Let me write it here. 0.0010538. That's good enough. Moles. And 3 sig figs would be right there. Yeah, let me put that up so you guys can see that a little better. PV is equal to nRT. T is equal to PV over nR. So T is equal to P, which is 1.2526, 3 sig figs atmospheres, times V, 0.023 liters, divided by N, this is very small, 0.0010538 moles, 3 sig figs, times gas constant, 0.082058 liters times atmospheres over moles times Kelvin. So what happens to the units? You guys see this? So I got atmospheres on the top, atmospheres on the bottom, liters on the top, liters on the bottom, moles on the bottom, and moles in the denominator of the bottom cancel. And what I have is technically 1 over Kelvin, which is going to give me Kelvin as an answer. 3. How many sig figs should I have, by the way? 3. Yeah, just 2. This volume here limits everything, right? It's 333.166, but if I only have 2 sig figs, it's going to be 330 Kelvin. So I found the temperature. Again, so what did we find last time? We found the pressure, we found the temperature. You could also find the moles, you could also find the volume.